All right, it's Friday, February 25th, I think. Remote day today due to ice, so I'm working as efficiently as I can to get our stuff done. The assignment here today is to do the section with the problems on limiting reactants, which starts on page 379. You should use your book. Read that, kind of pay attention to it a little bit, but solve these the way I'm solving them. And you'll do the practice problems 23 and 24. I'm going to do these right now. 25, 26, and 27. So follow along, do the work, try to pause it and do the next step, and then play it and see if you've done it the way I have. Now, when you do a reaction with more than one reactant, let's say you're burning something, you're not going to run out of the oxygen in the atmosphere. That's the excess reactant. You are really going to be concerned about the limiting reactant, because when you run out of the limiting reactant, that's when the reaction stops. For example, let's say you're making cookies and you got 6 ingredients. When you run out of baking powder, no more cookies. So the limiting reactant, in that case baking powder, would determine how many dozen you could make. And so you have to determine, using these parentheses in the stoichiometry, which one is limiting, and then use it. So there is nothing new to this process. You know all of the parts. It's just applying them. Okay, so first thing I'm going to do is, let me do this. I'm going to cut and paste. Get this on the other side. Okay, there we go. Our reaction on page 383. Number 23. Okay, it says the reaction between solid sodium, it's Na solid, and iron 3 hydroxide, oxide, iron 3 oxide, ordinary rust. Iron 3 means the charge is Fe3 positive, and you're going to combine that with oxygen. From the periodic table, you should know that oxygen is 2 minus. You're going to take 2 of these, 3 of these, you're going to move 6. You should remember how to do that. So that's important, because if you don't have Fe2O3, if this is wrong, your balancing will be wrong, everything will be wrong. So this is why we spent so much time on flashcards and chemical formulas. And start these to the left. You'd think after doing this thousands of times, you know I'd know too. This is typically solid. Okay, so they have that. So I gave you the equation here already. You shouldn't have done that. And it's going to probably be single replacement. We're going to get Na2O and iron. So this would be a way of producing iron. This is not the way they do it typically industrially, but it would work. This is one of the reactions that makes airbags work. There's actually a bunch of them. Now when you do this, the Na2O is solid. There's so much heat released in this, some of these might be gases momentarily. We've got to balance that. To make it quick, it looks like we're going to have a 6 here and a 3 there. You would do okay till you got to the O. Now the O would mean there's going to be a 3 there. Now I have 3, 6 sodium, 2 iron. Let me just double check to make sure that's right. Okay, and we have 100 grams of each. Aha. So we know we have 100 grams of this and 100 grams of this. Which one is limiting? You can't, it's not as simple as which one is there more of. No, so throw that out of your mind. How I do all of these is I use the first one to find out how much of the next one we should need. And that is grams to moles to moles to grams. So we are doing, if you use your mnemonic there, the whole thing. We're starting with grams A, where sodium is going to play the role of A, and we're going to have iron 3 oxide, this rust, play the role of B. So I'm going to turn this one, grams, into that. You must say, we already know how many. You understand we already know how many grams we have. What we don't know is how many grams we need to figure out which one we run out of and which one is excess. Okay, so do this the way I showed you. What are we looking for? I always use the first one to find the second one. So it would be easiest if you always did it the way I did it. Oops. Oops. I don't know why he does that. Let's get rid of that. Okay. So we want equals X grams Fe2O3. X equals so many grams Fe2O3. We're going to start with what we know over 1. The first question is limiting reactants, so we're going to find that out first. We are starting with 100 grams sodium. Over 1. Now we got to go grams to moles to moles to grams. So we're going to go moles Na. Na is playing the role of A. Moles of B, which is Fe2O3, to grams of B. Grams Fe2O3 over what? Okay, and this goes here. Grams Na, this goes here. Moles Na, this goes here. Moles Fe2O3. Okay, where does these numbers come from? Periodic table. A mole, if it comes from the periodic table, a mole is how many grams? I think for sodium that's 23. Pretty close to 22.9. Something. That one comes from the periodic table. A mole of Fe2O3, I don't know. To grab my calculator here. But I think iron's 55.8 change. So there's 2 Fe's at 55.8 is equal to 111.6, I think. Okay. And 3 oxygen at 16 apiece is 48. So adding that together, the number that goes here. Oh, by the way, just to keep that organized, I like to try to put that number in the same color as the PT thing. So this one, we use 23, and that one, 0.6, 1 and 8 is 9, 1 and 4 is 5, 159.6. These numbers are never anything other than 1 because this comes from the periodic table. A mole is this. A mole is that. Okay? Besides the fact, if you put these numbers in here and you think, oh, that should be a 6. If you put a 6 there, it cancels. So you can't do that. It's a common mistake for even students that know what they're doing. Just pay attention to make sure you don't do that. You are putting those numbers from the balanced chemical equation in here. This takes care of it. So we have 6 and 1. Make sure you have all your words and letters and numbers in there. Okay? Because I have people leave them out, and then guess what? They're the ones that don't know how to do it consistently. Grams in A cancels grams in A. Moles in A cancels moles in A. Mole iron 3 oxide cancels mole iron 3 oxide. The only unit left is grams iron 3 oxide. So what I'm going to do, okay, is take 100, here, 100, I'm going to divide that by, I'm not going to, okay, here, let me do it this way. Multiply the tops, 159.6 times 100 equals, multiply the bottoms, and then divide. I'm just going to divide twice. And I come up with 115.6 grams. Which means this. Which means this. This is how many grams I need of this. If I use 100 grams of sodium, I need 115.6. Teenagers classically make stupid decisions. It's what teenagers do. And my students often get the number and then they make the wrong decision about what's limiting. That's because that's what teenagers do. They make dumb decisions. I was a teenager, I know. If I need 115.6 and I've got 100, which one is limiting? This one. Because I'm not going to reach 115.6, the reaction is going to stop and there's going to be some of this left over. So the limiting reactant is Fe2O3. Now, I copied that page. There it is. Let me erase this top part, which is left on the previous page. Okay, the next question is, what is the reactant in excess? Okay, well, we can go back to the previous page. So this one is limiting, and there's only one other. This one is the excess. We are done with calculating using this one. Unless we want to know how much is left over, which I think we do. And by the way, this should say needed. Okay, so we want the reactant that's in excess. We just found that. Mass of solid iron produced. Let's use this one, the limiting, to determine that one. Okay? Okay, make sure we know this is the limiting reactant. Make sure you got the right one. Well, we're going to go grams. Again, grams to moles to moles to grams. Aha. So what we are looking for this time is equals x grams Fe. X equals so many grams Fe. And what we are starting with is 100 grams Fe2O3. Yep, I'm doing it right. I just had to check. I didn't want a bad mistake that was going to cost me a bunch of time. So 100 grams Fe2O3. Use the limiting over 1. All right, grams to moles to moles to grams. So grams to moles of A, Fe2O3 is playing the role of A. To moles of B, this is going to play the role of B here. So we are trying to find out, go ahead and label it, how many grams we want. So moles of B And then grams of B, grams Fe over something. Okay, I'm gonna move this a little bit. All right, so this goes here, grams Fe2O. Grams Fe2O3 down here, moles Fe2O3 down here, moles Fe. Here and here, we're using the periodic table to get those numbers. For a mole from the periodic table, for a mole from the periodic table. No, those numbers are never anything other than 1. We fix the numbers in this step right here. A mole of Fe is 55.8. And I think from the previous page we had a gram of Fe2O3 is 159.6. And we need the numbers from the balanced chemical equation. And they are, one of these gives us 2 of those. Now, multiply through the tops, multiply through the bottoms, and then divide. I'm just going to be divided by 159.6 because the other ones are 1s. So I have 100 times 2 times 55.8 equals, divided by 159.6 equals about 70 grams. Okay, which is what, whoops. About 70 grams produced. Okay. Now, let's say the mass of excess reactant that remains after the reaction is complete. Let's go to the next video.